Welcome to Wickerson Studios. It is Saturday, the 16th of January, 2021, and I am busy producing point clouds or point structures that can be put into meshes or put into surface from points. Very nice tools that these clusters I'm generating, and I'm giving them names. If you don't know, I've been through a series now of producing data, nodes that produce data, maths. This is the first math node, which is called the Wickerson Studio Trigonometric Function 001. There's points to meshes, there's points that generate curves, mainly point information, surfaces that are generated from points, and a couple of test scripts. I have these on GitHub. You can download them. They're available. My videos are actually now going to be unlisted, so if you're interested, you'll want to follow the GH Python or C# nodes. This one is tucked in and compiled, so you can't get at the access, but that's because I think the code and script is actually fairly intimidating to people that come new to it. But let's just take a look at the surface and see how these sliders, which can be changed and made huge, can have an effect on grabbing a surface. And that's probably very normal and common for most people to understand. I have a stretch, or I have a push and pull in the Z direction, so you can have a full expansion and contraction of that. I have number sliders here, one that's set much higher that goes up to 10 in 2 decimal places, and I have another one that only bounces between 1. And the reason is because of the trigonometric functions, you can see that they really have some awesome control. And I want to show you this little chair design that I don't know if anybody actually wants to make it, but playing through the frequency at a very low level because of the function that's in play, you can see that you can have this very cool, and think about rotating this in 4 directions and pulling off some very cool surfaces. Now, all of these I firmly believe are beautiful because they're enumerated through the basic math methods, functions that are within the math library. So if we go back down, the first one might be something like a sine curve. This can be extended very quickly, but maybe without extending the full size and scale of it. Let's think of it as points and change it in the Y and in the X direction, in the Z direction vertical. You see how that becomes a very nice surface. Now this will ripple out like crazy if I was to take these number sliders and maybe I'll just copy one here and show you the power of this script if you start changing scale to what you're doing. Let's go into here and just grab a edit tool. That's a snap tool, which I don't want. I want the edit tool. I'll bring this up to 110. And let's put that in the X and Y direction to 110 and see what happens to the script as I go. So let's pop that in the X and Y. And that should be able to, and of course I just did what I said I was going to do and then didn't do it because it's in my nature to make mistakes. But you see how I can stretch that out. And it does have some problems and it doesn't work at every snap. But what I'm trying to do is build that size and scale up and find out what actually operates well because of the math and numbers associated with it. So when you find one that actually works, you can go in there and you've got a pretty cool surface that you can not only take to surfaces being generated, to meshes that are generated, and to the point system that's generated. Very interesting to see what's actually happening in that surface as multiple surfaces are being produced. It's one untrimmed surface, but it folds backwards and forth over top of itself. Anyway, I'm going to keep my numbers set because I want to show you the complexities of what this script is really about. Let's put that one into there. And, oh, that's because I didn't change my count to make it susceptible. Sorry. If I'm going to plug in here and I'm going to plug in here, then I have to plug in my UV range on my final one to pull that out. And there you go. You got a very nice surface that's manipulable up in the 70 range. And maybe I'll leave that one just for here because why not? I'll just pull that one up. Because these are the sliders that I'm just plugging into it. Going back to that surface edit, I can stretch that. I can highlight it. I can make the frequency jostle and jam it. This one's not plugged in, but let's see how it operates at a small level. Very nice surfaces generated. And let's see what happens when I take it up into a bigger number range. There you go. You're just getting up into a huge frequency of wonderful pattern numbers to build that surface. Now, this is actually playing off of 1 enumerated value. So without making this too complex, let's take that angle down because it's going to explode. Let's enumerate through some other functions that are hidden in this node. And you're literally going through some math and trig functions that work. That's one that's cosine, and I just remember that. Now, this isn't something you have to know about. It's for the people that are maybe intimidated by trigonometry but want to play a little bit. I probably have some other functions in here, and this looks like it's just hit into tan because tangent's crazy on the number scale of what might happen. So let's pull that one down, and let's pull my Z range down into something manageable that we can see what's going on. Very nice pattern for surface. And this is the power and beauty of mathematics. And that's why I created this node, for you to discover something from a point cloud and how it's generated and how this is stretched out. You can just download the plugins. You can download this, put it up as a user object up in your ribbon tool, and you can play around with the sliders and have some fun in ways that maybe you never thought of doing before. And I'm in it for the math, and then I'm in it for the applications that other people come up with. Let's enumerate through the next function, which I can't even remember what it was, but it produces a nice flat curve, which isn't too exciting. I might have to bring up my Z to appreciate it, and there you go. It pulls up a nice canopy and a nice arch in that direction, which I still have control of. The size and scale as to what that might end up doing. This is a big number, but you can see how you can produce a pretty cool canopy that you still have your Z value to control the height of that. So let's leave our Z up high. Let's enumerate through the next one and see what kind of surface jumps. Keep in mind that you don't know the maths, and that flattens it a little more, so I have to probably bring up the Z count. It seems to level off like it hits an asymptote mathematically. So we've got that you can make a nice crisp edge. I think if I pull this one up here into the frequency, it's going to sharpen that edge almost right to it. And you can see what's happening in that mesh. It's becoming a sharper mesh. And if I take that number down in the frequency and play within, basically play between 0 and 1, play between 1 and 10, play between 10 and 100, and see what you end up building. Let's enumerate through another choice, and this inverts it. So that's kind of nice to think about that one. Go in here, and that sharpens the edge and really pulls it down fast. Even the minorest number has such an effect on that. But that's the power of exponential and logarithmic functions. And then you have to do something with the surface when you're done. And of course, as a smooth surface, it's pretty beautiful. Don't know if I'd actually end up scripting it. I do believe hidden within the math is where we generate ourselves from, and there's beauty within it. Let's enumerate up through the next one. There it is. Similar to what the other one was doing, but a different shape. We can take that and really explode that up. And it's something extremely, if I was to take this to the 5 count, you see that it explodes off the page. And why would I ever want a geometry like that? I can't tell you. And that's why I have these different frequency number sliders to play with. They don't come with the plugin. The plugin just comes with grab your math tool and pop it in and plug in your integers. It will say exactly what you need. It needs an empty integer parameter, empty number parameter, which means Z can be a float, frequency can be a float, and enumeration is going to ask for an interview. And if you go above 10, you're just going to reiterate through the next series. It's just going to loop around. Or I actually think if I take this number slider and go up to, say, 12 beyond what I have, if I can't satisfy the number, it defaults to my end value, which we're going to end up getting to. So maybe that makes sense to the people who have done some programming. Let's see where we go with it. Let's take the next one up. It's just a little small, so I'm having trouble with my number slider sliding it around. And every time I don't click my little button, there's the next one, 7, which produces a very flat shape. And I guess that just produces a very interesting mesh. And it's got a nice pattern in here, and I like seeing how that's generated as a pattern. It doesn't really change throughout that. The heights don't have an effect on that. It's not playing into the data. And I'm really literally just kind of stuck on the size and scale of that grid. So that's a function that doesn't do too much, but it was doing something, so I put it in there as well. The next one is this 8 count, which could be nice on this side. Let's take a look at it. It's got a nice little shape and a hook. You're producing some pretty fine grids between points that you get this really kind of different patterns that happen. If I went in and checked this out in a wireframe, you might find that interesting. I should put it in the curves, but you take a look at through different ways of viewing rendered. Let's put it over into shaded. I guess that's where I was. What happens when I play with this on a scale? It really just pulls that up and pushes it, but you get this really wonderful point tools that are playing with the flexibility and beautiful curves involved in this. And mind you, you can take these and make your X in a very small direction, carve off an area and make it behave in that direction, shorten that right down. So you can literally have a lot of fun with these tools. Keep them symmetric if you want, or play off of them. The last iteration is the one I'm most excited about because it's got this kind of stepped approach to what's happening. And I've got to pull my height down like crazy to really appreciate that. But you see that rippling effect. And this is where I was thinking more of furnishings and patterns. And the only way to really appreciate this is maybe all views. Let's zoom extends all. And then you're able to see, even if I bring my Z down a little farther, the pattern making that's actually happening throughout this iteration at a very low. You get this kind of step pyramid look. Very excited about this pattern. And I quite honestly cannot remember the function that was producing that, but it is nice to play off of that. You can put it at a smaller number and jump into it. If you're going to do that, you've got to change your U count to have that come out. But you can see here that I have this ability to very small numbers make these beautiful step pyramids that manipulate up through and become softer and softer. And with the infatuation with subdivisions that are happening now as forms in Rhino, I think maybe I'm getting there too late in the game, but I am producing some things that I wouldn't normally have done, let alone point systems that I wouldn't normally have done. That behave on a certain count or tree list item of where the data is. Might be very interesting for those who are into data information to have a look at what kind of things are happening within these branches. And with a little data tree programming, which I will evolve to, this could be incredibly a powerful tool. And so hopefully I'll call this my trigonometric function 1, and it'll become more complex as I go. The last iteration, I think, just defaults to the last one. I think it's just, and it's basically written as an enumerative function from if else, if else, if else, and then else statements. And if you're interested in that, I can provide that as well for you. So I'm very excited about this. I did want to see if it ran with my iteration of the final one, and if 12 just kept anything beyond. If you type in too big a slider, it only operates and enumerates up to 9. But here we go. We'll pull back down to that 3, which is that tangent function, and see how that starts to really. Actually, I thought it was the tangent 3. It might be 2 because I'm counting by. Yeah, there's the tangent. What actually happens with some forms. So bring your count down real low, and you've got a really nice mesh, let alone surface to play with. Hope you found it powerful. I hope you're interested in this plugin. I will provide that one along with my original 10 that I've been playing with. I've got another one here that's a pretty interesting. I'm not going to go over details with it now, but let's throw it into a group and show you that number 12 is a network surface applied to tween curves, list items, deconstruct breadth, and surface curves. But it basically produces, if I take this and make it enableable, it produces a wonderful point system that put into this surface edit. You get these, let me just grab that, you get this really nice surface edit, which was the beginning of this, a cosine sine kind of undulating form wave pool of what you could actually generate. So for those that are into stuff like that, really nice to think about. And they are my basic trig functions and why you might obsess about them, find them interesting. I'm so excited to finally find some applications for this through jewelry and design and architecture. And these nodes, the other node that's here, let me delete this one, which I called the trig surface 001 disable, not trig function. This one is actually called enable. And when I've done these ones on this map is I've shown you the code above it. So if you double click, you can actually see the script that's actually been compiled within it. I don't do that for every node because some things I think are too complex. People will lose interest. And if you want those details, you could ask for them. But this mesh is really one that came out of ALTV. Really wonderful to think about a mesh and how that would be generated away from a surface and how you can manipulate that. So even the dividing factor throws such a madness into here, kind of a subdivision, which is pretty interesting, and you can play with the heights and play with the changes. And they're highly conditional statements using basic Python skills, and you're left with some pretty cool geometry. So let's pop them all on top of one another. Maybe not. Just pop the last one on and have a look at that little surface edit for that final 9, which was that chair I was playing with. Oop. Let's plug in 9 here to enumeration, and we should have a nice little chair that's waiting to happen. And we'll pull back our values till we actually start to see it ripple. And I like this kind of pineapple type finish or surface on it. Anyway, Wickerson Studios, thanks very much for watching.